This is a very common question that looks at the use of the parallelogram inequality for vectors. So I can actually have a parallelogram here where I have the vector A, for example, going in this direction and the vector B going in this direction. And on the basis of it being a parallelogram and the fact that I can use inequalities to determine the diagonal here, that this Now we're going to look at a question on vectors. I have a parallelogram here, A, B, C, D, where I have the vector A, the vector B, and because of the fact that this is a parallelogram, that this vector AB is also parallel to this vector DC, so those two are the same, and this vector BC is also parallel to AD here, so these two vectors are the same. I also have a point E here. This point E is given by this ratio, that D to E in ratio to EC is 1 to 2. So this distance EC is twice this distance DE here. First thing it says is I need to come up with an expression for the vector DC using only A and B. So if I think to myself, well, D to C, as I said, is parallel to AB. So DC is equal to AB. And we know that AB is equal to the vector A. The next one I'm asked to find is, what is the vector CB? Well, the vector C to B is equal to the same as minus AD, because, as I said with my inequality, the vectors are going that way. C to D is going back that way, so it will be negative of what this bottom one here is, and so that's minus B. And then I now need to find out what DE is. So what is vector DE? Well, vector DE, if we think about our ratio, our vector is 1/3 of the vector DC, because it's one unit here, two lots here. In total, the sum would be 3. So there's 3 sections, or 3/3. So this is 1/3 of that, so it's 1/3 of A. And next, I need to find out, therefore, what B to E would be. So this is now a vector that runs from B all the way to E. That vector there. And this is where I need to use a little bit of vector addition. BE is the same as going B to C and then C to E. So BE is the vectors BC plus CE. Well, BC we know is the vector B because it's parallel to the vector AD. And CE, well, we need to find out what that is first. So let's determine what CE is. CE, from here to here, is 2/3 of the vector CD, which is the same as 2/3 and negative of the vector DC, because again we need to have it in the other direction. So that would be minus 2/3 of DC, and DC is A, so there we have. So therefore BE, this vector I needed to find, was going to be equal to B plus CE, CE being minus 2/3 A, and so our vector therefore can be given as B take 2/3 A.